everyone. So today is part 2 of chapter 13. I'm just going to kind of give you a big old long bucket list today. We're talking about costs, and there's a whole bunch of different costs, and so I think the easiest way or the most efficient way to go through this is just going to be to give you a long description of different types of costs, and I'll just kind of explain them point by point, and then we'll just kind of like draw them all together at the end so that way you can see how they fit. So today's going to be a lot of writing, so make sure you got your pencil handy and you're ready to go. Effectively, I'm going to make a long table here. So the first column of the table is going to be the type of cost we're looking at. The second column of the table is going to be the definition. And then the third column is going to be kind of the math of how you calculate that type of cost. Okay, so last class we talked about two types of costs. So I'm going to put these on the table so that they're all together. So the first type of cost we talked about was explicit costs. Okay, what is the definition of an explicit cost? An explicit cost is simply a cost that entails an outlay of money. So anytime you purchase something and you hand over a dollar bill for that thing, that's an explicit cost. You're actually paying for that thing. So the definition of an explicit cost is a cost that entails an outlay of money. Okay, there's not going to be a mathematical formula for this because different types of things could be classified as explicit costs. The other thing we talked about last class was an implicit cost. Okay, recall that economists care about implicit costs, accountants don't. So implicit costs are costs that do not entail an outlay of money, and specifically we think of these as opportunity costs. So it's whatever you're forfeiting or you're not doing because you've chosen another path. So it's kind of like the opportunity that you're missing out on, and that's the implicit cost of your behavior, your decision as a firm owner. So the definition of implicit cost is a cost that does not entail an outlay of money. And again, we think about these as opportunity costs. So the example I gave last class was if you are a firm owner and you take some of the money in your bank account and you go and you purchase something, well, the implicit cost is that money is not sitting in a savings account earning interest. So that interest that you have forfeited, that's an implicit cost of your behavior as a firm owner. Okay, again, there's not going to be a mathematical equation for this one, but the next type of cost will have a mathematical equation. Actually, it won't. I'm speaking too soon. Okay, the next type of cost is a fixed cost. Okay, a fixed cost is how we characterize costs that are not impacted by the amount of production that a firm engages in. So, for example, a fixed cost for a firm would be rent, because it doesn't matter if the firm owner, let's say he's a baker, it doesn't matter if he's not making any cookies or if he's making like 5 dozen cookies a day, he still has to pay rent, and that rent is fixed regardless of kind of how much production he's engaging in. Okay, so the definition of a fixed cost is fixed costs are costs that do not vary with the quantity of output produced. Okay, this isn't a mathematical formula, but I'm just going to put in this column how we denote fixed costs. So typically, to just abbreviate it, we call it FC, and that stands for fixed costs. Okay, another way you can characterize a cost is as a variable cost. Okay, a variable cost is going to be a cost that varies based on the quantity of output produced. So, for example, suppose you're a baker and you need to kind of use electricity anytime you're going to turn your oven on and bake cookies. Well, how many how much money you have to send to the electric company in your utility bill is going to be a function of how many times you stick cookies in the oven. So an electric bill would be an example of a variable cost because it varies with the quantity of output that's produced. The more cookies you make, the more electricity you have to use, the more your electric bill goes up. So a variable cost is costs or costs that vary with the quantity of output produced, and we abbreviate these as VC. So again, not a mathematical formula, but this is the abbreviation we use. Okay, the next type of cost is going to be a total cost. Okay, what is total cost? It's exactly what it sounds like, so this is not rocket science at all. Total costs are just the market value of all inputs that a firm needs to use to kind of be in operation. So if I'm a baker, then my total cost includes fixed costs, so I have to pay rent for the kitchen or the building that I'm using. My cost also includes my variable costs. I have to pay for electricity, which is variable. I have to pay for bakers, like people to come into the kitchen and work. That's a variable cost. The more people I hire, the more I have to pay in labor costs. And so total costs are just the summation of all those things. So the kind of official definition is a total cost is the market value. MKT is abbreviation for market. The market value of all inputs that a firm uses for production. Okay, so there's going to be a mathematical formula for this. So costs kind of come in two flavors. So costs come in flavor 1, fixed, and flavor 2, variable. So total costs are going to be the summation of fixed costs plus variable costs. Okay, so far so good. There's nothing kind of difficult or incredibly enlightening going on here. So just know these are 5 types of costs you need to know. So this is memory work. And now what we're going to do is we're going to start kind of thinking about how do we play with these numbers to calculate other types of costs that a firm might be interested in. For the sake of space, I'm going to erase these and keep adding on to the table at the top, but on your own piece of paper, keep on using this table and write down on the bottom. Okay, I'll keep the total costs row, so you can use that for a reference, and make some space up here. Okay, the next type of cost is going to be an average, and I'm going to abbreviate this, an average fixed cost. Okay, we talked about fixed costs. What are fixed costs? Fixed costs are costs that do not vary based on the quantity of output that a firm produces. Okay, if you take an average of a fixed cost, that means you take a firm's overall fixed costs and you spread it out across the number of units that the firm's producing, so you get an average amount per one unit that's coming off of the conveyor belt, effectively. So an average fixed cost is going to be the firm's fixed cost divided by the quantity of output. Okay, mathematically, how do you calculate this? You do what the words say. So you take the firm's fixed costs, which are going to be a dollar amount, you divide it by the quantity of output, Q, that's also going to be a number. Okay, once you take the total cost, the total fixed costs, and you spread them out across the number of units that are being produced, that's going to give you the average fixed cost. Okay, let's just think about how average fixed costs should kind of trend as a firm becomes larger. So fixed costs don't change, right? So rent is rent no matter how many units you're producing. Quantity kind of reflects like how big the firm is, like how much they're making. So as the firm gets bigger and bigger, average fixed costs are going to get lower and lower and lower, right? Because the numerator stays pegged at a particular number. As a firm ramps up its production, the denominator gets bigger and bigger and bigger. If the denominator gets bigger and bigger and bigger and the numerator doesn't change, this whole ratio gets smaller and smaller and smaller as the firm kind of starts producing more. Okay, now let's think about average variable costs. Okay, average variable costs are kind of using the same thought experiment. So the idea of an average variable cost is you would take the overall variable cost of the firm, so maybe their electric bills, and you're going to spread that out across the number of units that the firm's producing, and that will give you the average amount of electricity, for example, average electricity kind of cost per one cookie or whatever it is that the firm is manufacturing. So the definition of an average variable cost is the variable cost divided by the quantity of output. So mathematically, you just take variable costs, you divide it by quantity, and that's the formula. Okay, the next type of cost is average total cost. So we've got total costs down here. Total costs are just fixed costs plus variable costs, and now we're thinking about average total cost. So the idea of an average total cost is we're going to take all the costs that a firm incurs, no matter what kind of flavor of cost it is. We're going to spread those total costs over the number of units that a firm produces, and that's going to be kind of the average cost of producing one unit. Okay, so the definition is average total costs are total costs divided by the quantity of output. Okay, mathematically there's going to be two ways you can calculate this. One way is you can do explicitly what I've written. So you can take total costs and you can divide it by the quantity of outputs. Another equivalent way to calculate average total cost is you could take average fixed costs and add to it average variable costs. So I'm going to put an or here. Or you could take average fixed costs plus average variable costs. Okay, really quickly, I'll switch colors here so you know this is like just an extra side thing that doesn't need to go on the table. Let's think about why this is equivalent to this. Okay, average fixed costs are fixed costs divided by quantity. Average variable costs are variable costs divided by quantity. So if you add these two things up, recall if you add fractions, the denominator is the same. You just keep the denominator, you add the numerators. So this would be fixed costs plus variable costs divided by Q. This whole numerator is the same thing as total cost. So this is the same thing as total cost divided by Q, which is the same thing up here. So all of that is to say this is mathematically equivalent to this. Okay. Actually, I'm going to say that. I'm going to give you one more cost, and then I'll kind of start giving you some more stories to help you pin this down a little bit. Okay, the last type of cost that we're going to think about today is marginal cost. Okay, what is a marginal cost? So we talked last time about marginal product, or kind of like the incremental increase in production. So marginal is kind of incremental, product is like production. So now we're thinking about marginal, incremental cost. Okay, conceptually the idea of a marginal cost is, let's suppose a firm wants to increase their output, their quantity of output by just 1 unit. So maybe they want just like one more extra widget to come off the conveyor belt, or they want one extra cookie to sell in their shop. So they're increasing the quantity of output by 1. The marginal cost is how much would the cost, the total cost of the firm, change if they wanted to offer 1 more unit for sale. So it's the incremental change in the firm's cost when they produce one more unit. Okay, so official definition is marginal cost is the increase in total costs, TC, that arises from one extra unit of production. Or another way you can think of an extra unit of production is an increase in the quantity of output that's equivalent to 1. So a 1 unit increase in the quantity of output. Okay, mathematically, how would you calculate marginal cost? Okay, marginal costs are going to be the change, so delta, in total costs divided by the change in the firm's output, their quantity. I'm not going to dwell on this, but if you're a mathy person, you would calculate marginal costs using derivatives. So you would take the derivative of the total cost function with respect to quantity. Okay, so now what I'm going to try to take apart for you is let's think about average total cost to begin with. Okay, if we wanted to plot average total cost, let's think about kind of the shape that we would anticipate. So for space, I'm going to erase this. Okay, so let's just think about the shape we would anticipate if we're plotting average total cost. So if we're going to plot average total cost, then on the vertical axis, we would probably have a monetary amount, the cost. Along the horizontal axis, we would probably have the quantity of output, Q. And average total costs are the total costs divided by the quantity. Okay, what's going to be true is that average total cost curves are going to be U-shaped. Okay, let me write this out on the board so you can have it in your notes, and then we'll kind of unpack it a little bit. Okay, so in terms of pictures, average total cost curves are U-shaped, and the reason for this, so they're U-shaped because average fixed costs are always falling as Q increases, and average variable costs are typically increasing as Q increases. Okay, and then one thing I had in my notes, I'll just tack on at the end. The reason average variable costs are typically increasing as quantity increases is because of diminishing marginal product. So we talked about this last class. Diminishing marginal product is this idea whereby if you hire one more worker or you use one more machine, then that extra worker, that extra machine, in other words, the input, it does increase output, but that last incremental increase in the input doesn't yield as much extra production as the input before it. So the idea is that average variable costs typically get higher and higher as you kind of expand production because the extra inputs that you need to generate the quantities are doing kind of a less efficient job the bigger and bigger the firm gets. So average variable costs are typically increasing as quantity goes up because of diminishing marginal product. Because of diminishing marginal product. My handwriting is especially messy today. I apologize for that. Okay, so this is the first thing to just know. So average total cost curves are U-shaped. Let's now think about marginal cost curves. So marginal costs, again, are kind of equivalent to a derivative. And you think about what does a derivative represent? A derivative represents a slope. Okay. marginal costs intuitively are kind of like how much do costs go up as total cost increases. Okay, there's going to be a very specific way that marginal costs and average total costs relate to each other. Marginal cost curves are going to be upward sloping because the idea is that as you increase the quantity, the total costs are going to change, and the amount of the change is going to kind of magnify as the firm becomes larger. So marginal cost curves typically are going to just kind of slope up if we're plotting the firm's size or amount of production against the cost, which is marginal cost. Okay, so what that means for you, let me write here, is that there's going to be an explicit link between the shape of the average total cost curve and, or the position of the average total cost curve and the position of the marginal cost curve. Okay, so I'll write this down here and then I'll draw you a picture, put it all together. Okay, the idea of marginal costs is that anytime the marginal cost of a firm is less than the average total cost of the firm, the average total cost is going to be falling. This will make sense in 1 minute, but let me write it down first. And anytime the marginal cost of a firm is greater than the average total cost, the average total cost is going to be rising. And also recall that the marginal cost curve has to be kind of generally upward sloping, and the average total cost curve has to be a U-shaped. Okay, let me draw this so that you can understand what it looks like when you put it together, and then let me give you a story so that it kind of illustrates what I'm trying to tell you here. Okay, so let's draw the cost curves together. So on the vertical axis of this graph, we're going to have the cost, and on the horizontal axis, we're going to have the quantity of output that the firm produces. Okay, we said that a firm's average total cost curve is going to be U-shaped. And what we also said is that anytime the marginal cost is less than the average total cost is falling. So let's think about where on this graph average total cost is falling. Okay, average total cost is falling. Now it's increasing. Okay, so left of the bottom of the U, average total cost is falling. Okay, what does that mean? That means left of the bottom of the U, the marginal cost has to be less than or below the average total cost. Okay, the average total cost is here. What is less than the average total cost? This whole area over here. Okay, what that means is that the marginal cost curve has to reside in this kind of like shaded area, which is underneath the average total cost curve when the average total cost curve is falling. Okay, second part of this. We also know that the marginal cost needs to be above or greater than the average total cost when the average total cost is rising. Okay, where is average total cost rising? Average total cost is falling. Average total cost is rising. Okay, so right at the bottom of the U, to the right of the bottom of the U, average total cost is rising. What does that tell us about the relationship between marginal cost and average total cost in that region? Well, right of this point, the marginal cost is above the average total cost. Okay, if this is the average total cost, then above the average total cost is this area here. So we know that the marginal cost curve has to be situated in this region and in this region. And I also kind of briefly told you the marginal cost curve generally has to be like sloping up. So what that means is that the only way we can get these conditions to be satisfied is if we draw a marginal cost curve that is here. it intersects the average total cost curve at the bottom of the U, and then it keeps going up. So let's think about why this marginal cost curve satisfies all the conditions. This marginal cost curve is underneath the average total cost curve for this whole region where average total costs are falling. Check. Okay, this marginal cost curve is above average total costs for this whole region where average total costs are rising. Check. Okay, so this gives us another important result, which is that the marginal cost curve, if I can find a marker that works, the marginal cost curve will intersect the average total cost curve at the minimum of the average total cost, or the bottom of the U. At the minimum of the average total cost curve. Okay, so what you need to make sure is always characteristic of the curves that you draw is that, one, average total cost curves have to be U-shaped, and two, marginal cost curves have to follow these properties where the marginal cost curve is underneath average total costs as long as average total cost is falling. It hits the bottom, it intersects the average total cost curve at the bottom of the average total cost curve, and then marginal costs need to be above the average total cost for the whole range of quantities where average total cost is increasing. Okay, now let me tell you the story. So this is a lot of just kind of technical stuff today. The easiest way to understand kind of the relationship between marginal and average is to think about a bowl of water. So suppose you've got a bowl of water, it's sitting on your kitchen counter. That bowl of water has some temperature to it. That temperature is going to be like the average temperature. It's going to be the temperature of your dorm room or your apartment or your house. Okay, suppose you have now a tablespoon of water that you're going to add to the bowl. Okay, and another thing, so this tablespoon of water that you're adding to the bowl, this is going to be a marginal contribution to the average bowl. Okay, if your marginal contribution, your tablespoon of water, has a temperature that's less than the temperature of the bowl of water, so if you have like a freezing cold tablespoon of water, and you add that freezing cold tablespoon of water to the bowl, what happens to the temperature of the bowl, the water in the bowl? It all kind of becomes a little bit colder. So the average temperature in the bowl will fall if the marginal contribution, that tablespoon, is colder than the average. Okay, conversely, think about what would happen if your tablespoon of water that you're adding to the bowl was like scalding hot. So your marginal contribution had a temperature that was higher or hotter than the average temperature of the water in the bowl. Well, if you take a tablespoon of boiling water and you add it to a bowl of room temperature water, what happens to the temperature of the water in the bowl? It becomes a little bit hotter, and so the average temperature of the water in the bowl is going to rise as a result of the marginal contribution being hotter than the existing average. Okay, that's helpful for me to remember when I'm trying to think about how the marginal cost curve fits with the average total cost curve. The idea is anytime, again, the tablespoon of water is colder than the average temperature in the bowl, you add in this cold tablespoon of water, it brings down the whole average. Then, if you have water that's hotter than the average, it's above the average total cost curve, if you add that hot tablespoon of water to the bowl, the temperature of the whole bowl kind of increases. Okay, one extra thing I'm just going to quickly tell you and then leave for you to read on your own if you're interested in it, is this same relationship that characterizes how marginal cost links together with average total cost is also going to kind of characterize how marginal costs link together with average variable costs. So recall the average total cost is made up of average fixed cost plus average variable costs. Okay, what that means is because average variable cost is a component of average total costs, average total costs are going to be lower than average total costs because average total costs are like the whole thing, average variable costs are part of the thing. Okay, so average variable costs are also going to be U-shaped for similar reasons. The average total cost curve is U-shaped. And what's also going to be true about average variable cost curves is that they're going to follow the same pattern as this. So anytime the average variable cost curve is falling, the marginal cost curve is going to have to be underneath it. Anytime the average variable cost curve is rising, the marginal cost curve is going to have to be above it. Okay, so let me draw this neatly one time so you can make sure it's super clean in your notes. And then after that, we'll do an exercise. Okay, so here's what you need to know in terms of how costs are drawn. Okay, so when we draw costs, again, if you just put a monetary value on the vertical axis, and that means you can just kind of overlay different cost curves on the same plane. So when we draw these, we're going to have just a generic cost label up here. So this is going to represent a dollar amount. And then the horizontal axis is going to have the quantity of output. So like how many units a firm is producing. Okay, always, 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 these need to be drawn such that the average total cost curve is U-shaped. The average variable cost curve is also going to be U-shaped, and it's also going to be underneath the average total cost curve because it's just a component of average total costs. And then the third thing that needs to characterize this is that the marginal costs, which again increase as output goes up, need to hit the bottom of the average variable cost curve, hit the bottom of the average total cost curve, and then go up from there. So when you draw it this way, everything's satisfied. Again, when average total costs and average variable costs are falling, marginal costs underneath it. When average total costs and average variable costs are rising, marginal cost is above it. And this only happens when the marginal cost curve hits at the bottom of the U's. Okay, so that's a lot for today. If you have any questions during the next 10 minutes, let me know, and then we'll meet back and let you practice a little bit. For today's exercise, you're going to do a little bit of reverse engineering. So what I have is a table that's partially filled in, and I'm going to have you fill in the rest of the table. So suppose you have a firm, and if they make these different levels of output, these would be their corresponding total costs. So in other words, if they didn't make anything, their total cost would be $3. If they made 1 unit, their total cost would be $3.30. If they made 2 units, their cost would be $3.80, and so forth. Okay, each of the different columns that you have to fill in is going to be a separate exercise question. So for question 1, I would like you to fill in the numbers that need to go into this column. So I'm going to help you a little bit here. Okay, fixed costs. What are fixed costs? Fixed costs are the costs that a firm incurs that are independent of their production. So if a firm's not making anything and they still have a total cost of $3, then that means those $3 have to be their fixed costs. So the number that would go in this first row here is $3. And then what is true about fixed costs? They're fixed. So if they increase their output to 1 or to 2 or to 3 or to 4 or to 5, the fixed cost won't change. So this is the easiest kind of question in the exercise. Fixed costs are just going to perpetually be 3 all the way down. So just keep filling that in. Okay, question number 2 is, what are the firm's variable costs? So recall that fixed costs plus variable costs equal total costs. So, in other words, if you take a firm's total cost and you subtract out the fixed cost, that's going to leave the variable cost. So in the first row, if they have a total cost of 3 and they have a fixed cost of 3, then that means there's no variable cost because the whole total cost is just fixed. So in this row, you're going to have a 0. The next row, suppose the firm has a total cost of $3.30. Among their total costs, 3 of those dollars are fixed. That means the remaining 30 cents are variable. So again, to get variable costs, you take total costs minus fixed costs. That gives you variable costs, which here is going to be 30 cents. I'm going to do one more for you. Suppose the firm has a total cost of $3.80. Their fixed costs are $3. That means the difference between these two numbers of 80 cents are going to be the variable cost. Okay, and then you keep going. Okay, question number 3 is calculate the firm's average fixed cost. Recall the equation for average fixed costs are fixed costs divided by Q. So this is Q, the first column. So we can't divide by 0. So in this first row here, we're just going to put an NA. In the next row, the firm has a fixed cost of $3, a Q of 1, so 3 divided by 1 is $3. In the next row, the firm has a fixed cost of 3. They have a Q of 2, so $3 divided by 2 is $1.50, and you keep on filling out numbers. Question number 4 is fill in the numbers for the average variable cost. Okay, recall average variable cost is variable cost divided by Q. So in the first row, since Q is 0, we can't calculate it because you can't divide by 0. So we're going to put another NA here. In the second row, the variable costs are 30 cents. The Q is 1, so 0.3 divided by 1 is 0.3. In the next row, the variable costs are 80 cents. The Q is 2, so you would take 80.8 divided by 2. That's going to give you 0.4 or 0.40. And then you keep on going. Okay, question number 5 is calculate the average total costs. Okay, average total costs are just total costs divided by Q. Like we've been saying before, you can't divide by 0, so we're going to put an NA in the first row. And then in the second row, we see that total costs are $3.30. Q is 1, so $3.30 divided by 1 is $3.30. In the next row, total costs are $3.80. Q is 2, so $3.80 divided by 2 is $1.90, and then you keep on going. And then the last column here is marginal cost. Okay, marginal cost, again, is the change in the total cost divided by the change in the quantity. So, let's suppose we're calculating the marginal cost when we go from 0 units to 1 unit. So we're changing the Q from 0 to 1. Okay, if we're changing the Q from 0 to 1, then that means the change in the quantity equals 1 between these two numbers. That's the denominator of the marginal cost. The numerator of the marginal cost is how much total cost changes when you change the total cost, or change the quantity. So the change in total cost is equal to 30 cents. So marginal cost is 0.3 divided by 1, and it's going to be 0.3. So technically this number kind of needs to go between rows, but you can just move it down to the second row. So the marginal cost of the first unit is 30 cents. So when you go from making nothing to making 1 unit, total cost go up by 30 cents. Okay, let me do one more of these for you. So suppose we're thinking about the marginal cost of going from making 1 unit to making 2 units. So the change in quantity here is 1. So marginal cost is how much do total costs change in this segment here. So if you go from making 1 unit to 2 units and total costs go from $3.30 to $3.80, then the change in total cost is 50 cents. Recall marginal cost is the change in total cost divided by the change in Q. So it would be 0.50 cents divided by 1. So this would be 0.50. And then you keep on going down. So just to be really clear about what you need to put in the Blackboard, you need to calculate the rest of these numbers. So you'll figure out the numbers for each of these columns, and then the easiest way to type it in is just to write question 1, and then type in 3333333. Question 2, type in 0, 0.30, 0.80, keep going, keep going, and then do the same thing for the rest of the questions. Okay, this is what you need to turn in. One extra thing that would be super helpful for you to do if you want to just help your own understanding is to plot the average total cost and the marginal cost curve. Okay, how would you do that? So the way you would do that is you would have a graph that has cost on the vertical axis. It has quantity on the horizontal axis. You would first take the average total cost numbers here and you would plug them in. So the horizontal axis over here is quantity. So when the quantity is 0, average, circling the wrong thing. So when the quantity is 0, average total costs are nothing. When the quantity is 1, average total costs are $3.30. So you would go over 1, up $3.30, and draw a dot there. Okay, when the quantity is 2, average total costs are $1.90. So you go down to the graph at the Q equals 2 notch, you would have a dot at $1.90, and then you would just keep going. Okay, you would do the same thing for marginal costs. So marginal costs are here. You would plot marginal costs against quantities to get your marginal cost curve. Okay, the reason this is going to be helpful for you to just kind of verify that it all hangs together is because what we said is that when you plot these curves, what needs to be true is that the marginal cost curve needs to intersect the average total cost curve at the bottom of the U. So if you plot these, what you should get is an average total cost curve that's U-shaped, so it'll kind of go down and then come back up. And then the marginal cost curve will go up and it will hit the average total cost curve at the bottom of the U. So in the table, that means that the average total cost number should match the marginal cost number whenever this column gets to its minimum value. So look down the average total cost column after you calculate it all, find the smallest number. Okay, wherever that smallest number is, whatever quantity you're thinking about there, that average total cost number should match the number that's in the marginal cost column at that quantity. If you actually do it, it'll make more sense. You don't need to turn in the picture, but this, again, is just going to be really good help for you. Okay, so that's the exercise. Oh, actually, one more thing I want to tell you, because I forgot to put this in the lecture, so I'll make this a one-sentence kind of fill-in. The minimum at the average total cost curve has a name to it. So I'm just going to put this in here, and so you can be aware of the name. So the minimum of the average total cost curve is called the efficient scale. Okay, so what that means is if you have an average total cost curve that looks like this, wherever the bottom of the U is, that quantity is consistent with the efficient scale. Because again, recall that firms, they want low cost. So this is the cost that corresponds to the lowest possible average total cost that the firm could have. Okay, so what I was going to tell you is this is the end of chapter 13. So your next reading assignment is chapter 14. So on your own, read, my red marker is struggling, read chapter 14 before next class, and then we'll start in on that next time I see you. So good luck on this, and enjoy the rest of your day.